Going over to number 15 now. Here we have two linear equations. We know they're linear because x and y are to the first power. Now we don't have x or y, we have r, p, and w, but the point is nothing is squared. So it's a linear situation. That's very important because the number of solutions for two lines is a reference to something. Now, mind you, a moment ago, we talked about the number of solutions for a quadratic, which is a reference to the idea of the discriminant. But the number of solutions for two lines is a reference to the idea that the lines can have one solution if they hit once. And if they hit once, that means that the slopes have to be different. They can have no solutions if they never hit. In other words, they're parallel. And that would happen if the slopes are the same, but the y-intercepts are different. And they'll have infinite solutions. They'll always be hitting if the slope and the y-intercept are the same, because the two lines have the same address. You can almost think of them as the same line. But instead, mathematically, they're actually two lines that are overlapping each other. So all of this implies getting your equations into the y equals format so we can really make sense of the slope and the y-intercept. So coming back to our question, we know that P is a constant. That means that P can't be used as our X or Y. And because a constant is not like an X or a Y, an X or a Y, an X value or a Y value, they're always changing. As X is one thing, Y is another thing. But P, or any letter that's a constant, once you find that value, it'll always remain the same. So we kind of had a liberty here to decide which one we want to treat as our Y. So let's treat R as our Y. So that means that W will be our X. So if we're thinking of this as an XY combination, it would be W, comma, R. Once again, as long as P is not one of these guys, this is our X, this is our Y. So if we're getting this into Y equals mx plus B, that means that we actually have to solve for the R value for both of these equations. So let's do that. Let's solve for R and get it into like a Y equals mx plus b format. So for the first equation, we can take away 6 from both sides. 7r is pw minus 6. And then we can divide by 7. R equals p over 7 times w minus 6 over 7. So this was a careful little thing because when we were dividing by 7, we could have said w over 7 times p, which is equivalent. But we want mx plus b. We want y equals mx plus b. So the thing that goes into this spot right here has to be the x. And we want to know what's in front of the x because that'll tell us what's our slope. So we have one of the equations in y equals mx plus b, r equals p over 7, w minus 6 over 7. Now, the other one is a tiny bit more work. Let's start that one. 7r minus 5w equals 5w plus 11. And we're going to solve for r. So let's add 5w to both sides. We'll have 7r equals 10w plus 11. And divide by 7 on both sides, r equals 10 over 7w plus 11 over 7. So once again, this is in our y equals mx plus b format, and the thing in front of the x, or in front of the w, well, that's our slope. Now, according to these rules, we heard that if you have no solutions, that means that your slopes have to be the same, they're tilted the same way, but the y-intercepts have to be different. So here, there are no solutions in this situation. And so we need the slopes to be the same. And if we were pressed on it, we'd have to make sure the y-intercepts are different. So on a harder version of this question, we have to prove that we understand that the y-intercepts can't be equal. In any case, if the slopes are equal, that means that p over 7 must be equal to 10 over 7. And look how easy that is. P simply equals 10, and that's our answer.